Welcome to Metrology lecture series. In the present video, we will discuss the introduction of gear metrology and need of gear measurement, types of gears, gear terminology, and errors in spur gears. Let's see the introduction of gear metrology. Gears are toothed wheels used to transfer power or motion from one shaft to another without slipping. Because there is no slip, gears provide a constant speed ratio, which is very important in machines. So gear systems are highly efficient with about 99% of efficiency, which means very little energy is lost during power transmission. Even though gears are efficient, small errors in their shape or size can cause the problems such as the noise, vibrations, reduced efficiency and shorter life of machines. For smooth working, gears must be made with high precision and must be mounted on proper shafts and the bearings. Let's see the need for gear testing. Before using gears, we must test and measure them carefully to ensure correct size and shape, proper tooth profile, smooth meshing between gears, and also have to measure the distance between the shaft must be correct for proper engagement. If large distance are needed, a gear train is used. The maximum recommended speed in gear drives is about the 250 meter per minute. Effect of poor alignment. If gears are not properly aligned or have defects, then vibrations and noises will occur and power loss increases and also machine performance is reduces. So inspection and measurement of gears are very important. Next we will discuss the types of gears. First one is the spur gears. Spur gears are the most commonly used gears for transmitting power. So in the spur gears, the teeth are straight and parallel to the axis of the gear, and spur gears are used to transmit power between the two parallel shafts, and moreover spur gears are simple in design and easy to manufacture. Because of this simplicity in design and manufacturing, spur gears are widely used in machines, gearboxes and mechanical systems. So next type of gear is the helical gear. Helical gears are similar to spur gears, but their teeth are cut at an angle to the axis of the gear. Because of this, the teeth form a helix around the gear. So let's see the advantages of the helical gears. Helical gears operate more smoothly, produce less noise and vibration, and moreover, helical gears can handle higher loads and speeds. Next type of gear is the bevel gears. Bevel gears are gears in which the teeth are cut on a conical surface instead of a flat surface. Previously we seen the spur gear and helical gear where the teeth are cut on a flat surface, but in the bevel gears teeth are cut on a conical surface. In bevel gears teeth are on a cone shaped surface. So bevel gears are used to connect shafts whose axes are intersect. Most commonly, bevel gears are used when shafts are at 90 degrees. Next we have to see the types of bevel gears. There are the two types of the bevel gears, that is the based on the bevel teeth. First one is the straight bevel gear. So in the straight bevel gear, teeth are the straight, and second one is the spiral bevel gears. In the spiral bevel gears, teeth are the curved shape. So there are the special case of the bevel gears are there, that is the meter gears. When the shafts are at 90 degrees right angle and both gear are of the equal size. Such gears we are calling as the meter gears. And let's see the applications of the bevel gears. Bevel gears are used in automobile and right angle drives, gear systems where direction of motions need to change. In these cases, we have to go for the bevel gears. And next type of gear is the worm and worm wheel. A worm gear system consists of two parts. One is the worm, which is looks like a screw, and second one is the worm wheel, which is looks like a gear. In general, worm wheel are used to connect the shafts are non-parallel, non-intersecting, usually arranged at 90 degrees. So this worm and worm wheel provides the very large speed reduction. So small rotation of the worm should provide the very slow movement of the wheel. Similarly, this worm and worm wheel used when high torque and low speed are needed. Advantages of the worm and worm wheel are so these can achieve high speed reduction in one step, and this operates smoothly and quietly, often self-locking. This worm and worm wheel having the self-locking. Next type of gear is the rack and pinion. So in the rack and pinion consists of the rack and the pinion. Rack is a straight gear and pinion is a small circular gear. The rack is like a spur gear with infinite radius. The pinion meshes with the rack to the transfer of the motion. So let's see the function of the rack and pinion. So rack and pinion are the convert the motion from one form to another, rotary motion to linear motion, or maybe linear motion to the rotary motion. Applications, in general applications of the rack and pinion are the car steering systems, machine tools, linear actuator, CNC machines. And last one is the internal gears. Internal gears are the gears in which the teeth are cut on the inside surface of a ring. So in the internal gears, teeth are on the inner side of the gear. These internal gears are used to connect two parallel shafts and suitable when the distance between the shaft is very small. So functions of the internal gears are the helps in transferring power efficiently in compact spaces, and internal gears can provide speed reduction within a small setup. And advantages are the compact design, smooth and efficient power transmission, commonly used in planetary gear systems. Next we will discuss the gear terminology. Before going to discussion of the gear measurements, we should know the gear terminologies. First one is the addendum circle. So addendum circle is the circle that forms the outer boundary of the gear teeth and shows the maximum diameter of the gear. Next one is the addendum. Addendum is the radial height of the tooth from the pitch circle to the tip of the tooth. So it is the radial distance from the pitch circle to top surface, tip of the tooth. We are calling as the addendum. And next one is the dedendum. So dedendum is the radial depth of the tooth from the pitch circle to the root of the tooth. So pitch circle to root of the tooth, the distance we are calling as the dedendum. Next one is the clearance. The radial distance from the top of the tooth to bottom of the tooth space in mating gear is called as the clearance. And next one is the face of the tooth. It is the side surface of the tooth above the pitch circle and perpendicular to the plane of the gear. Next one is the flank of the tooth. It is the side surface of the tooth below the pitch circle perpendicular to the plane of the gear. And next one is the tooth thickness. It is the thickness of the tooth measured along the pitch circle. So this is the tooth thickness. Next one is the hole depth. Hole depth is the sum of the addendum plus dedendum of a tooth. So addendum plus dedendum we are calling as the hole depth. Next one is the working depth. It is the greatest depth to which a tooth of one gear extend into a tooth space of a mating gear. So working depth equal to the addendum plus dedendum minus clearance. And next one is the dedendum circle. So dedendum circle is the circle which contains the bottoms of the tooth spaces. It is also called a root circle. Its diameter is the root diameter. Next one is the pitch circle. In a pair of machine gears, imaginary circles are assumed on each gear as if they are smooth wheels rolling together without slipping. Each of these circles is called a pitch circle and its diameter is known as the pitch circle diameter. Pitch point, it is the point of contact between the pitch circle of two gears in mesh. And next one is the crest of tooth. It is the outside surface of the tooth perpendicular to the plane of the gear. Next, root of the tooth. It is the junction of the tooth with the material at the bottom of the tooth space. Next one is the base circle. It occurs only in involute gears and it is the circle from which the involute curve of the tooth profile is generated. So next we have to discuss about the circular pitch. So in the schematic you have to see this is the circular pitch. It is the distance measured along the pitch circle from one point of the tooth to corresponding point of the adjacent tooth. For spur gear, circular pitch PC equal to the pi d divided by capital T. So this is also we can be written as pi into m, where small d is the pitch circle diameter, capital T is number of teeth and small m is the module. Next one is the diametrical pitch. It is the number of teeth per unit length of pitch circle diameter. So mathematically diametrical pitch equal to number of teeth divided by pitch circle diameter, which is the capital T divided by small d, where capital T is number of teeth, small d is the pitch circle diameter. Next one is the module. It is the linear distance in mm that each tooth of the gear would occupy if the gear teeth were spaced along the pitch diameter. Mathematically, module equal to pitch circle diameter divided by number of teeth, which is equal to small d divided by capital T. And module is the reciprocal of the diametrical pitch. And next we have to discuss about the line of action and pressure angle. So first we have to see the line of action. When two gears are mesh, their teeth touch each other along a straight line is called as the line of action. This line is a common tangent to the base circles of the both of the gears. The force between the gears is transmitted along this line. Next one is the pressure angle. Pressure angle is the angle between the line of action and the tangent to the pitch circles. It can also be understood as the angle between the normal at the contact point and the line joining the centers of the two gears. Next we will discuss the errors in spur gears. Since gear inspection is a large topic, usually studies focus on spur gears with involute teeth as they are most commonly used. So we are studying the errors in gears mean errors in spur gears. Before learning how to measure gears, it is important to understand the errors that can occur during manufacturing of the spur gears. We know that spur gear is a rotating part that continuously meshes with another gear. For smooth and efficient transmission of power and speed, it should have perfect shape and dimensions without any defects. From a measurement point of view, the main types of errors are listed below. First one is the gear blank runout errors. Second one is the gear tooth profile errors. Third one is the gear tooth errors. Fourth one is the pitch errors. Fifth one is the runout errors. Sixth one is the lead errors. And last one is the seventh one, assembly errors. So we will discuss briefly one by one. So first one is the gear blank runout errors. So it is the not in the gear blank. In general, gears are made from a gear blank which is produced by casting or forging. So this blank is made by the casting process or maybe forging process. Before cutting the teeth, the outer surface and both sides are roughly machined. So before going to the final stage, we have to, in the intermediate stage, we have to cutting the teeth, outer surface and both sides roughly machined. In this stage, in this roughly machined stage, some errors can occur, such as the uneven rotation of the outer surface and wobbling of the faces. These errors are too high. It will be difficult to produce an accurate gear in later step. So this error we are calling as the gear blank runout errors. Next, second one is the gear tooth profile errors. So profile, it will be changes. Gear tooth profile error happens when the actual shape of the gear tooth is different from the ideal shape or correct shape. If the tooth is more than required, that is we are calling as the positive error, then teeth rub against to each other, it will increases in friction. Similarly, if the tooth is less than the required size, then we are calling as the negative error, and it makes the gap forms between the teeth. It will be result in backlash occurs. So too much error can cause either friction or backlash. Next one is the gear tooth errors. Gear tooth errors mainly occurs in two forms. One is the tooth thickness error and tooth alignment error. Tooth thickness error, the thickness of the tooth measured at the pitch circle may be incorrect, which may be too large or too small. And second one is the tooth alignment error. The path followed by a point on the gear tooth may not be perfect, so the teeth are not perfectly aligned. These gear tooth errors reduce the smooth working and efficiency of the gear. So next error is the pitch error. Pitch errors are very important and cannot be ignored, especially when gears are used for precise movement. So these are all the two types. First one is the single pitch error. It is the difference between the actual and correct distance between the two adjacent teeth. In the schematic you have to see. So actual and the correct one. So this distance, this difference we are calling as the pitch error, single pitch error. Second one is the accumulated pitch error. It is the total error that builds when measuring the pitch over the several teeth. It is the distance between the expected total pitch and the total actual pitch over the multiple teeth. So these pitch errors are affect the accuracy and smooth motion of the gear system. Next one is the runout error. Runout error refers to the uneven rotation of the pitch circle of a gear. Instead of rotating smoothly, the gear slightly moves in or out. In the schematic, you have to see. It may be move in or out. This causes vibrations, noise and reduce the life of the gears and the bearings. These runout errors usually occur due to inaccuracies in the cutting arbor and tooling during the manufacturing. Next error is the lead error. Lead error occurs when the gear tooth does not follow the correct path along its length or the face width. In other words, the actual position of the tooth is different from the ideal position. This lead error causes the improper contact between the mating teeth, which leads to loss of power and inefficient operation. Next type of error is the assembly errors. Assembly errors occurs when gears are not properly fitted together. These errors are mainly of two types. One is the center distance error. Second one is the alignment error. Let's see the center distance error. If the distance between the two gears is incorrect, it can cause the backlash or jamming. And second one is the axis alignment error. The shaft of the both gears should be parallel. If not, it leads to the misalignment error, which causing improper contact and wear. So these assembly errors affect smooth operation and can damage the gears. So this is the regarding the introduction and errors in the gears, and thank you.